In today's digital age, we rely heavily on fast and reliable internet connections. Whether we are streaming movies, attending video conferences, or simply browsing the web, the speed of our network plays a crucial role. Two fundamental concepts that determine network performance are bandwidth and throughput. Understanding these terms is essential for optimizing our online experience. Bandwidth and throughput are often used interchangeably, but they represent distinct aspects of network capability. While bandwidth refers to the maximum amount of data that can be transmitted over a connection in a given time, throughput represents the actual amount of data successfully transferred during that period. Think of it like a highway. Bandwidth is the number of lanes available, while throughput is the number of cars that actually pass through. Having a high bandwidth connection is like having a multi-lane highway. It provides the potential for fast data transfer. However, just like a highway can get congested with traffic, various factors can affect the actual throughput of a network. These factors include network congestion, signal interference, and limitations of the devices involved. In the following sections, we will delve deeper into the concepts of bandwidth and throughput, exploring their differences and providing practical examples to illustrate their significance in real-world scenarios. By understanding these concepts, we can make informed decisions to optimize our network performance and ensure a seamless online experience. Bandwidth is often compared to a highway. Imagine a highway with multiple lanes. The more lanes the highway has, the more cars can travel on it simultaneously. Similarly, bandwidth refers to the maximum amount of data that can be transmitted over a network connection in a given amount of time. Bandwidth is typically measured in bits per second or its multiples, such as kilobits per second, megabits per second, or gigabits per second. A higher bandwidth indicates a wider data pipe and therefore the potential for faster data transfer rates. For example, streaming a 4K movie requires a significant amount of bandwidth. A 4K video stream typically demands around 25 megabits per second. If your internet connection has a bandwidth of 50 megabits per second, you should be able to stream the movie smoothly without buffering. However, it's important to note that bandwidth is not the sole determinant of actual data transfer speeds. Other factors like network congestion and device limitations also come into play. Think of it this way. Even with a 10-lane highway, if there's heavy traffic, cars will move slowly. While bandwidth represents the potential for data transfer, throughput reflects the reality. It is the actual amount of data successfully transmitted over a network connection in a given time. Returning to our highway analogy, if bandwidth is the number of lanes, throughput is the number of cars that pass through a specific point within a certain time frame. Several factors can affect throughput, including network congestion. Just like rush hour traffic slows down cars, heavy network traffic can reduce throughput. When multiple users share the same network connection, the available bandwidth gets divided, potentially leading to slower speeds for everyone. Signal interference is another factor. Wireless networks are susceptible to interference from other electronic devices, which can degrade signal quality and reduce throughput. Physical obstacles like walls and furniture can also weaken wireless signals. Device limitations also play a role. The capabilities of your computer, router, and other network devices can impact throughput. An older router, for example, might not be able to handle the same data speeds as a newer model. In essence, throughput is a more accurate measure of the actual speed you experience when downloading a file, streaming a video, or browsing the web. It takes into account the various real-world factors that can influence data transfer rates. Section 4: Key differences, bandwidth versus throughput. To summarize the key differences between bandwidth and throughput, let's look at a table. Feature: bandwidth, throughput. Definition: theoretical maximum data transfer rate, actual data transfer rate. Measurement: bits per second, BPs, bits per second, BPS. Analogy: highway lanes, number of cars passing through, factors affecting technology. Subscription plan, network congestion, signal interference, device limitations. Understanding these differences is crucial for troubleshooting network issues and optimizing your online experience. Section 5. In the office, a real-world scenario. Let's imagine a busy office with 50 employees. The office has a high-speed internet connection with a bandwidth of 1000 Mbps or 1 Gbps. This means theoretically the office network can handle a massive amount of data transfer simultaneously. However, on a typical workday, the actual throughput experienced by each employee might be significantly lower than the maximum bandwidth. During peak hours, when multiple employees are simultaneously uploading large files, participating in video conferences and browsing the internet, the network can become congested. Despite the high bandwidth, network congestion can lead to slower download and upload speeds, buffering during video calls, and increased latency in online gaming. This scenario highlights the difference between bandwidth and throughput. While having a high bandwidth connection is essential, it doesn't guarantee optimal network performance. Factors like network congestion and device limitations can significantly impact the actual throughput experienced by users. Section 6. Measuring throughput, speed tests explained. To measure the actual throughput of your internet connection, you can use readily available online speed tests. These tests typically measure download speed, which is how fast your connection can download data from the internet to your device. They also measure upload speed, or how fast your connection can send data from your device to the internet. Additionally, they measure ping or latency, which is the delay or time it takes for a signal to travel from your device to a server and back. Several websites and apps offer free internet speed tests. To perform a test, open a web browser and search for Internet Speed Test. Choose a reputable speed test website or app and then click on the Run Test or similar button. The speed test will send and receive data packets between your device and a test server. The results will show your download speed, upload speed, and ping in Mbps. It's important to note that speed test results can vary depending on factors like network congestion, server location, and the device you're using. Running multiple tests at different times can provide a more comprehensive understanding of your internet connection's performance. Section 7. Conclusion. Understanding network performance. In conclusion, understanding the difference between bandwidth and throughput is crucial for optimizing your network experience. Bandwidth represents the maximum potential for data transfer, while throughput reflects the actual amount of data successfully transmitted, considering real-world factors. By comprehending these concepts, you can make informed decisions about internet service plans, troubleshoot network issues effectively, and optimize your network configuration for better performance. Remember, a high bandwidth connection is like a multi-lane highway, but traffic congestion and other factors can still slow things down. By monitoring your throughput and understanding the factors that affect it, you can ensure a smoother and more efficient online experience.